What is going on, my seniors? Hey, it's me, Mr. Rodriguez. If you're watching this message, guess what? I'm not here. You're like, yes, yes, he's not here. Well, I'm gonna make it this an easy day for you guys. I'm gonna do a little bit of lecture of Module 8. Maybe I might get through the whole thing. I don't know. It's really short, honestly, but I don't think we're gonna get through all of it. This particular one deals with VPN and IPsec, and so we're not going to do any configuration. There's just going to be a lot of descriptions, describing and explaining how it is used, right? So let's get started, so that I can give you guys the rest of the time to work on last minute pressing things like catch up on your work or senior projects that are coming up soon, next few weeks. So let's get this started and get it out of the way. So VPN. VPN stands for Virtual Private Networks, right? And they're used not just to circumvent, like I said earlier, the school Wi-Fi and restrictions that we have placed. Although that is a great use for them, they're not used for that only, right? As you see here, right, they create an end-to-end point connection, right? And not only that, they create a tunnel. Um, Now, just because that tunnel is created, you're like, does it go through different routers? No, it uses the same routers, but what happens is it creates an additional security over your traffic. So your traffic might be secure already, using maybe some different technologies, right? And how it goes, the traffic is routed through the network, but this adds another layer of security into that. You can never have too much security when it comes to networking equipment, network security. Okay, so it VPNs allow us to communicate from private network to private network, using public internet or public networks, right? We know that when we're communicating via our ISPs, our network is not, we're not always on the same network. So I might be communicating on CenturyLink network right now, but this data has to communicate through other networks to get to where it's going to go. So I might leave CenturyLink's network eventually, and it might be using another carrier's, right, server or router, and we don't know beyond our routers who is really in charge of those devices. Are they using my data for what? Are they using my data for any other reason, right? So those are one of the things. VPNs kind of protect that traffic. They encrypt it, right? So it allows that confidentiality, right? So some benefits of VPNs, right? So the modern VPNs use IPsec, right? And SSL, secure socket layer, to secure your network traffic, right? So cost savings, what do they do? You can save some money, um, while using VPN. Security, obviously, that's the big one, right? The whole reason why you're using a VPN is to secure your traffic. No one can read your traffic, where it's going from point A to point B. So in reality, what they're just seeing is you're connecting to this from this server, and this server is encrypting, and nothing else can be seen. So, kind of one of the reasons why you're allowed to connect to, websites that are being blocked by, um, the school's network. Okay, scalability, right? VPN will allow us to add new users without really having to add infrastructures, right? There's VPNs that are software based, and it's pretty easy to implement. All right, so there's not bad compatibility. Implementation is pretty easy. You can use it across a wide array of devices, mobile devices, laptops, computers themselves, right? So a lot of devices can use that VPN, right? You can so anyways, continuing on, site to site and remote access VPN. So a site to site, I have a VPN at my business, and I have a VPN at my other location, right? That's site to site. You create that connection between the two sites, right? So VPN is terminated on the gateways. In this case, this router is the gateway, and this device that they're showing right here, this is called a firewall, an ASA device. But it's basically a router with upgraded components, right? So you have this gateway, it acts as a gateway VPN. So basically, your connection, your encrypted connection, terminate on these ends. Well, in between here, then is no longer, right? The client doesn't know that there's a VPN happening between them, right? Between part A and part B. So this is non-client based. Basically, it's a network-based VPN, right? Site to site. Then you have the client-based VPNs, right? This is what you guys are used to. You download a VPN client onto your phone, onto your device, and you are connecting to a gateway, right? That gateway is that server, right, that creates that VPN connection to the outside world. So you connect to the VPN gateway, and that VPN gateway is basically then your access point to wherever it is, right? You can connect to a server that's located here in the US. You can mimic like you are in Germany, et cetera, et cetera, et cetera. Now you might the server itself might be located in Germany. You might see higher pings because or higher latency in your traffic because you're connecting all the way to another country. So that is, again, the traditional what you guys would know, a client-based VPN connection. That's basically site-to-site remote VPNs. I just call that the client to based. So non-client based, this is just a gateway to gateway, and then this is a client-based client to gateway VPN. All right, so we have different kinds also, they can be managed differently. You have enterprise managed VPNs, right? The enterprise, whenever we say enterprise, is just a company, right? The company is just basically managing that VPN. We might have devices. We might just say, okay, everyone's going to be we're buying this VPN. We're buying NordVPN, right? This lecture brought to you by NordVPN. Enter the code RODPOG 2020 and you will get 0% off of NordVPN. But anyways, we just say that, okay, we're buying a site license for this VPN product, and that's what we're going to be using, right? That's an enterprise, right? Managed somewhat. You could also buy, devices themselves, Cisco devices if you want to, or some other devices that have the ability to create a VPN for you, and you can do that as well, right? Again, we use IPsec VPN or GRE over VPN. Then you have the service provided managed VPN, where the VPN itself is provided to you by the internet service provider. So they use MPLS, multi-protocol label switching, layer 2, layer 3. So at each of those layers, they can use MPLS to do that. Legacy solutions we don't really care about. Frame relay, ATM we don't really talk about that anyways. But they can create that VPN channel for you, so you don't have to worry about it on site. Again, that might be a premium kind of service. All right, so let's go into more types of VPN. Remote access VPN. So remote access VPN. You have two types of remote access. You have the clientless, right? So you just use a web browser. This typically you know this as when you go to a website and it has SSL. It has a secured. It has a secured. It has the security already built in. Sometimes we are using kind of a VPN. Sometimes when we don't need to have the client, we actually just connect to our headquarters or our workspaces network using a browser, and that creates that VPN tunnel for us. We don't have to actually connect to anything, right? So we can have the client list type, that's just with the browser, or we can have the client-based VPN, like I said before. It's the one that you guys are used to. You download the client, you create an account, and you log in with that account using your credentials. Voila, you are using a VPN, right? We call it a tunnel because it's what it does. It creates a tunnel just for personal use or your own use for your own data. That tunnels that traffic to and from site to you. Again, it's still using the same routes, the same routers, and the routes is just that it creates an envelope. That's why we call it a tunnel. It creates an envelope around those around those data packets, um, an envelope of encryption. All right, moving on. Let's see. SSL uses the public key infrastructure and digital certificates or authenticate peers. Right, the type of VPN method implemented is based on access requirements of the user's organization's IT processes, and so this table will compare the different IPsec and SSL remote access deployments. Right, so what kind of features do you want? Application supported, right? What does IPsec do? What does SSL do? Remember, SSL is usually a more browser-based kind of deal sometimes, right? So application supported, what do we support? IPsec will do all IP-based applications, while SSL is only web-based and file sharing capacity. What is my authentication strength with IPsec, right? We have really strong certificate, right? Two-way authentications and shared keys or digital certificates. SSL only has a one-way or two-way, so it's considered moderate. Encryption strength, we have some pretty strong encryption, right? Remember the higher bits of encryption that we have, the better it's going to be to encrypt our data, right? SSL has moderate to strong too, right? Low 40s all the way up to 256. And I think actually these can go higher. I think we're in the 512s, 1024s kind of deal, depending on what we're using. But for now, we'll leave those numbers as is. Complexity, right? It's a medium. You're going to need a VPN client. And so when we start including clients, we're going to have, you know, once we involve the user having to download and some things, not all users are tech savvy, and so that's why we give that a medium, because you have to have the client in order to use IPsec. SSL, not really. You log into a browser, right? Let's just say right here, right? I'm using Connection Secure. Learn more. Learn more. Would you like to know more? It's not telling me. It used to tell me what the certificate was. Oh, there it is down there. Certificate, right? Issued by who's the certificate, who is issuing the certificate, right? And a lot of times it would tell me what also other things that it would allow me to use, but it's not. I'm not getting that. I'm not getting that from here. Let's see. Yeah, he used to say, "Oh, it's you were using SSL over TLS kind of deal," and I'm getting less information. That's strange. But anyways, it's okay. Details. I'm using a algorithm of a SHA-256 hash, so it's hashing my algorithm using SHA-256. Um, that's basically a form of kind of encrypting. But my public key is an RSA 2048 bit, so that's my encryption right there, the RSA 2048. That's a huge key, right? That's a lot. That's a lot. All right. So just know that what are we using? Oh, version ones. It says it's version 3, but version 3 of what? Is it SSL? I'm just telling you what the certificate is here. It's okay. Going back to what we were talking about. All right. So, and connection options limited. Only devices with specific configurations can connect. They must have the VPN client. So only ones. If you don't have the VPN client, guess what? You ain't getting on. Whereas with SSL, anything with the web browser can use it. Okay. Site-to-site VPNs, right? So like the first one that we saw earlier, right? You have a gateway and you have another gateway. You don't have client doesn't know that you're on a VPN. That's all managed by some intermediary devices or routers, right? So end hosts send and receive normal unencrypted TCP/IP traffic through a VPN. The VPN gateway encapsulates and encrypts outbound traffics for us. So basically, all the VPN stuff is happening at our gateways. Again, the client has no knowledge that it's happening. Generic routing encapsulation, or GRE, right, is a non-secured site-to-site VPN tunneling protocol. We don't really, we talk about GRE and what it does, and you should know what GRE is. as far as what its capabilities are, but we're not going to be doing um, any configuration of GRE over IPsec. And I don't think that's anything that you have to do on the exam either. Cisco doesn't have any labs based on it, but they do want you to know about it. So the reason for GRE is so that you can encapsulate some other protocols, right? So it says right here, right, multicast and broadcast traffic over it, right? So GRE does not by default support encryption, right? So that's why you need to have IPsec. So using GRE over IPsec, but GRE is necessary so that we can have communication with router to router. Okay, so a GRE packet can be encapsulated into an IPsec packet to forward it securely to the destination VPN gateway, right? So it says right there, look at that, standard IPsec VPNs, so anything without using GRE, only uses unicast traffic. What if we are trying to send other kind of traffic over our VPN, like we wanted to send, some multicast type information? We can't. So that's why we use GRE, right? So it says right there, GRE into IPsec allows multicasting routing protocol updates. So OSPF updates, right, is a multicast protocol that needs to be updated. Without GRE, we would not be able to use OSPF to update all the routers. So therefore, we need GRE. Again, this goes and explains a little bit more about how that works, right? We have the IP, which is a transport protocol, and we throw GRE in between that, and then some passenger protocol, which is your layer 3 kind of stuff, right? So passenger protocol is the original information, right? Your IP4 or IP6 packet, whatever, all the data. That's the regular stuff. The carrier protocols are GRE, right? Which is encapsulated on top of that. And our transportation protocol encapsulates over all of everything else, right? So IP protocol or the IPsec encapsulates over that. Then you have GRE, and then you have everything else. All right. Again, this is just another picture of how it's exchanging. Again, they use the example that I threw out there, OSPF, right? Example, branch HQ, branch and HQ want to exchange OSPF information over a VPN, right? An IPsec VPN. We need to use GRE. So GRE over IPsec is used to support the routing protocol traffic over the VPN, specifically OSPF packets, which is the passenger protocol. That's going to be the right here stuff right here. Our passenger protocol is our OSPF information, right? Would be encapsulated by GRE, that's our carrier protocol, and subsequently encapsulated into that tunnel. So you have the tunnel over everything, then you have the GRE that's over the original packet. And that's how they can communicate. It's a lot of stuff just to be able to communicate OSPF. So all you need to know that the reason we have GRE is so that we can have that important um, other kind of information communication that's required. In other words, OSPF some multicasting packets that need to be communicated, especially with protocols like OSPF, EIGRP, and all those other ones. Dynamic multi-point VPNs, DMVPNs. All right, so it says site-to-site IPsec VPN GREs over IPsec is not sufficient. When the enterprise will add more sites, so this is what I just talked about earlier was great for a site-to-site, but what if we have more sites? How are we going to do that? We need a DMVPN, right? It will simplify that tunnel configuration, right? And basically makes it a little bit easier, right? We have the hub and spoke configuration to establish that full mesh topology. So basically what happens is that each site is going to configure a multi-point or an MGRE, multi-point GRE, to allow us to be able to support those multiple or dynamic multi-point multi-point VPN. So just think of it hub and spoke, but we're doing a full mesh as well. And this basically allows us to build, if we have a huge network of multiple sites and we're using VPNs to communicate with each other, to be able to communicate like that. Okay. The IPsec virtual tunnel interface. Um, Basically, it's supposed to simplify your configuration process. Again, you need to know what this is. You're not actually going to do it. The next module doesn't even go into how to configure IPsec VPN. They just want you to know what it is because they want you have some knowledge of this. But this is actually won't be applied until a further Cisco course, if you so decide that you want to take that further Cisco education, go beyond a CCNA, right? This is more into the um, enterprise solutions and enterprise configurations. Service provider MPLS VPNs. Basically, they're just talking about the ISPs, how they use MPLS in their core network. So basically, they just provide VPN solutions. I mean, there's nothing here that is riveting stuff, guys. Read about it. I'm just going to tell you the rest of the chapter. You should just read about it. Watch this. Definitely watch this video on IPsec. Um, Basically, it's going to tell you a little bit more about it, or at least discuss more. So IPsec, it says, is an IETF standard, defines how VPNs can be secured across networks, and they do that using these functions. Confidentiality, right? We talked about the CIA triad, right? Confidentiality, integrity, and um, confidentiality, integrity, and not access. I think that's what it stands for, access. But without one of those, we lose our, secured network. Well, we use some of those same concepts: confidentiality, integrity, right? Authentication is the last one. I'm sorry, not access. Authentication. And then they just add this last one. I don't know why they add Diffie-Hellman. It's one way to secure exchange keys, but the CIA triad is something that we use in network security. Again, without the CIA, that CIA triad, we don't have a secure network. We lose one, we lose a very secured network. So they go on here to tell you that IPsec itself is not bound to any specific rules for secure communication. So therefore, it makes it easier to integrate other or new technologies. In other words, if you see right here, IPsec protocol, we have different protocols. Which confidentiality? It's almost like a mix and match. Choose your best, choose which one you like, which one you want to socket in IPsec. Okay, based on what you socketed in IPsec, you have these choices for confidentiality. Which one do you want to use? Based on that, you'll have this for integrity, and so on and so forth. What you have, right? So as it says right there, right, the open slots in the IPsec framework, as shown in the figure, can be filled with any of the choices that are available for that IPsec function to create a unique security association. This one looks like they messed up the writing over here. So choosing the IPsec protocol encapsulation in the first building block of the framework, they IPsec encapsulates packets using the AH or authentication header or encapsulation security protocol. The choice of AH or ESP, encapsulation security protocol, AH or ESP plus AH, establishes which other blocks are available. Again, like I said, whatever you pick first, then it will be left available what's next. They tell you which one, pros and cons of which. AH is appropriate only when confidentiality is not required or permitted, right? So if you don't need confidentiality, AH is what you want to use. ESP will provide both the C and the A, confidentiality authentication. So we're probably going to go with ESP for most cases, right? Confidentiality, we're going to go into what is confidentiality. Confidentiality is basically um, is my um, are my messages going to remain visible to those who I want them to be visible to, right? With confidentiality, if I send you a message that's confidential only to you, and there should be no way that anyone can intercept that message, and the only one that can read it is you, right? I have a key, I send you the key, but then there's also a code for that key. You can't open that key without the code, or you can't use that key without the code. In conjunction, those two will allow you to read the message. Okay, that's confidentiality kind of in a nutshell there. All right, that's the second square, right? What's going to be my confidentiality? And they tell you, right, which one's the least secure, starting from the left all the way to the right, the most secure. And that just goes on to the length of the keys themselves. 56 bits is shortest, and to the 160 bit as a long one. Okay. Integrity, the next box, right? Just means that it's a way to check that our data has not changed in transit, right? So we use what's called a hashing methodology. We can use, there's a lot of different hash generators, right? The most popular ones are MD5, the Message Digest 5, and the SHA algorithm, secure hash algorithm. We usually use SHA-256. If you notice, I kind of showed you that when I went into here, right? Valid, and I look at the details, and we're using a SHA-256 as our algorithm. RSA is my public key. That's my key that I was using back here. I have it open twice, right? RSA is the authentication. I'm sorry, going down there. All right, we might not be using confidentiality in that, but in this case, right, our message digest, basically it takes the message and it does a hash, and with that hash, what it does is that it creates basically a a, um, a checksum. That checksum will then be compared once it's sent. So if I create the checksum on my end, right, I send you the message. When you receive the message, you're gonna rehash it and do a check, get your checksum that you calculated from that, and you'll compare the one that I sent to the one that you created. If they are equal, then that means that your message arrived in its full integrity. Nothing was, disturbed along transit, right? Authentication just is, you know, um, can are those who are allowed to see this message are allowed, right? So we use different ones. PSK, which is the least secured, to RSA. RSA is the most common one. We're going to be using RSA pretty much most of the time because of just PSK is pretty old. No one uses it because it's pretty easy to crack now. So RSA. And RSA stands for that. Rivest, Shamir, and Adelman. And then how do these keys exchange? Well, they call it the Diffie-Hellman handshake. I believe that's what it's called. And they have different groups, and of course they all have different, bits and all that stuff. So there's a video, basically IPsec transport and tunnel mode. That's just going to go into more, and we are done with module 8. Very quick and painless module. Um, that's pretty much it. This should be most of your class, or half of the class at least. So for the rest of this class and the rest of next class, what I want you to do is the following. I have created this visual vocab for Module 8. That's going to be due March 5th. Not this Sunday, but next Friday. So a week from tomorrow, when you see this, a week from today, because you'll be watching this video in class. So March 5th is in 1 week. You'll do that. Then you have until midnight. Then that is the last day to turn in any work. So what I'm gonna do is I'm gonna give you the time that you have left in fourth period, and during sixth period, I've advised or I've instructed the sub to let you basically what you're going to be doing is you're going to be working on the rest of the time either catch up on late work. If you're already caught up with any late work in my class and any of your other classes, then work on your senior projects. Okay, that's pretty much your objective for the rest of the class period. All right, guys. Other than that, if you have questions, email me. You know my email, so I'll get back to you as soon as I can. I hope you guys have a great weekend, and I will see you on Tuesday.